So all of today, we're going to talk about specifically just the topic 8.7, which is volumes with cross sections with squares and rectangles. We'll save the triangles and semicircles for next class, and we'll also probably need to finish talking about squares and rectangles because we're only going to get through probably like 3 out of the 4 examples for the square and rectangle problems, okay? So we were doing area between 2 shapes, or 2 curves, right? So we were finding 2D area. Now we're going to find 3D area, so we're adding in another kind of axis here. So like if I had this not Sharpie, this is a expo marker, right? If I wanted to find the volume of this expo marker, I could. I'm going to just like pretend that the top's not there, right? If I took a cross section of this, what's my cross section going to look like? If I like cut it in half, it's going to look like a circle, right? If I cut it in a half vertically, what's that going to look like? A rectangle. This is actually kind of just basically a cylinder, right? If it did not have the top on there. Okay, we already know the formula for a cylinder, so that's not terribly complicated. But if we have something that looks like this shape here from Kansas City, I don't know how to find the area or the volume of something like that, but with calculus, you can, okay? So what they're basically doing, what we're doing today, is we're taking all of these different cross sections, specifically rectangles and squares, and we're like stacking them next to each other between the 2 curves to create a 3D shape. Okay, so what I mean by that is there is a what's it called? A thing in GeoGebra, like a little tool, I guess I should say, that if you click into it on Schoology, you're able to kind of play with it a little bit, but this is what shows up. There's a 3D plane here, and we have these 2 curves. I have this blue curve and this red curve, and then I've got a bunch of rectangular squares kind of drawn in here between that from 0 all the way up to, I think it's about at 1, maybe a little bit less than that, okay? So now, like when we were talking about Riemann sums and things, right? If we have larger like rectangles, it's not going to be as accurate, right? But if I have teeny tiny squares or rectangles and I have a ton of them, then it's going to be pretty accurate, right? So if I can't slide it on here, but on the actual thing you can slide it, and you can move it all the way to the right-hand side here. If I took this N and moved it all the way over, that would increase the number of squares that I have to look something like this. So it actually creates a solid of all of those squares put together. And if you look in really, really close, those are all just like teeny tiny little squares put together. Okay, so it's this volume or this shape that's created by a bunch of squares stacked on top of each other. Okay, so we can find the volume of this shape by using integrals. Okay, so that's like what we're doing today. So the 2 formulas here, if we integrate area, what is my area units? Like what is the units for area? Squared, right? It's units squared. And if I integrate my units squared, I end up getting units cubed, which is my volume. Okay? So when we are taking cross sections, similar to what we were talking about with vertical slices and horizontal slices, when they are perpendicular to the x-axis, that means you are going to have a vertical slice that you are looking at. So it's going to be with respect to x with your integrals. If we are looking at perpendicular to the y-axis, how's that going to change? To horizontal, right? We're looking at the horizontal or the y values for my integrals. And then inside here, it needs to be in terms of y, okay? So for today, and for the AP test in general, you do need to know the 4 main formulas for square, rectangle, semicircle, and then triangle, okay? If you don't remember those, we're going to talk about them today in next class, so you can remember those then. But we need to just know the basic formula. So like if I'm given a square, what do I need in order to find the area of a square? Base times height, which is actually just going to be the same thing, right? Base and height are the same. So let's just call it a side length. We'll call it S. So we were required to have a side length. We'll call that S, which means my formula or my area formula would just be S squared. Okay, what 2 things do I need for a rectangle? Length and width. So I'm going to say my length is L and my width is W. And if I found the area of that would be just length times width. So now we're going to take these formulas, we're going to find the area of our square or our rectangle, and then we're going to integrate that and solve to find out what my volume of that shape that is created with all of those cross sections of squares and rectangles is going to equal. Okay? So, looking at example 1 here, it says to find the volume of the following solids in which the base is the region bounded by the graphs of the square root of x and x squared. So, animation of this is at this URL, or it's a link in Schoology as well. It's the picture that I just showed you, okay? So, I'm going to go ahead and draw this. I'm going to color code here a little bit. So, my square root of x, if I were to draw this on the graph, this would look something like that. And if I were drawing x squared, my graph would look something like this. Okay, so this is my 2D plane. But now what we're going to do in this 2D plane is we are going to add cross sections to create a solid and find the volume of that newfound solid by adding all of those cross sections of squares. Okay. And part A specifically says we're looking at perpendicular to the x-axis. So I'm finding horizontal or vertical slices here. Vertical slices. So I'm taking and finding the volume of this shape when we add in my square cross section. So I'm cutting this here. This is technically a square. You kind of imagine that 3D square. It's not great, obviously. I'm not an art teacher there, but I just want you to know it's a square. It's not just a line, right? So we're having a bunch of squares put on to that shape there, and we're going to find the volume of that, okay? So let's first find the side length, okay? My side length is going to be my top curve minus my bottom curve, okay? So my side length is the red one, so square root of x minus x squared. Okay, if we're talking about squares, squares are, to find area, we just times it by itself, right? So the area formula would be the square root of x minus x squared, and then square that. Okay, now to find volume, I just have to integrate my area, okay? Where am I going to integrate my area from? What are my x bounds going to be here? 0 to 1, okay? So I'm going to integrate this function for volume from 0 to 1 of the square root of x minus x squared squared. Okay, technically this is one that can be done by hand. We're going to do part of it by hand, but then we're going to use our calculator to finish it out just because there's not a whole ton of space here for this problem. Okay, the hardest part for this section and the kind of this whole unit here is as you guys were finding out on that Delta Math, like there are very silly mistakes that you can make with signs, positive, negatives, when we're multiplying, things like that, right? So we got to be really careful here when we're doing the algebra. I would highly recommend squaring this out before you take the integral of it. So if I distribute this, if I FOIL it out, I'd have the integral of 0 to 1. I'm just going to rewrite it really quick. Square root of x minus x squared squared times the square root of x minus x squared. Oh, sorry. I don't need to write that twice. So they're being multiplied together here. Okay. So when I FOIL this, what's the square root of x times the square root of x give you? X. And then square root of x times negative x squared. If I think about that, that's x to the second times x to the 1/2. So if I have the same base, what do I do with my exponents? Add. So this is actually x to the 2 plus 1/2, which is 2 plus 1/2. So 4 over 2 plus 1/2 would be 5/2, right? So I've got minus x to the 5/2. And then if I multiply the others, here I got negative x squared times that same thing. So I'm going to have another minus x to the 5/2, right? And then lastly, negative x squared times negative x squared, that gives you what? X to the 4th, and it's positive, right? Okay, I would simplify this one more time. So this would be the integral from 0 to 1 of x minus, how many x to the 5 halves do I have? 2. So I could write 2x to the 5 halves plus x to the 4th dx. Now that I've got it separated into just addition and subtraction, could I integrate each of these pieces individually with adding 1 to my exponent and dividing by that number? Okay, that's great. We're not going to spend time on doing that right now. I want you to plug this in the calculator and see what you get. You can either plug this in, or you could plug in the original function that we had way up here, right here. So 0.129. And then technically, since we just found volume, that would be units what? Cubed. Yep. Okay. So that's the volume of the shape that was created that I showed you on that previous slide or the previous page here of like that, all those purple squares put together in that solid there. Okay. All right. We're going to skip the equilateral triangles and the semicircles, move down here, and we are going to talk about cross sections of squares. So example 2a we're going to look at. 2c will be our last example for the day. So I've got 3 equations here, 3 functions. I'm going to color code, do 3 different colors here for my graph. I'll do red, blue, green. Okay, what are the red, or actually all of these, what are they when I graph them? What are they going to be? Just lines, right? Lines with either a slope of positive 1/2 or negative 1/2, or it's just a horizontal, or no, vertical line. Okay? So starting at positive 1, going down over 2. Oops. And then start at negative 1, go up 1 over 2. Just got really quiet in here with that. That's wild. And x equals 0. Okay. So yes, the area that is included, or in bounded here, I guess I should say, that's where we're going to create our solid that's bounded by all 3 of those graphs. Okay. Now, inside that base that's a triangle, I am putting a ton of squares, really, really thin squares together. Okay? So we're doing cross sections to the x-axis, so very similar to how we set up the other one. So if I want to find out what this side length is going to be here, I'm going to take what minus what here, if I'm talking about the colors of my lines, to find my side length here. My red minus my blue, right? So for my side length, it's my red function, which is 1 minus x over 2. And then we're subtracting my blue function. Notice how I have parentheses here, so that way I don't make a silly mistake when I'm subtracting this stuff, because you're subtracting the entire quantity. Okay, so if I simplify this, I have a 1 minus a negative 1, which gives me 2. And then I've got a negative 1/2 x minus a 1/2 x. What's that give me? Negative x. So the side length is 2 minus x, which means my area is just 2 minus x squared. That's the area of just one square. But if I'm finding the volume of my cross sections here, I am going to integrate my area formula. We got to check, what are my bounds going to be? Where am I going from and going to? 0 to 2. So I go from 0 to 2. Should have a dx there. And now again, I know you guys should be able to solve this by hand, but go ahead, plug this into your calculator. Let me know what you get. 2.66 repeating. So we'll call that 2.67. And again, that's units cubed. Okay. All right. Can we lock in for one more quick example? I know you guys can do it. Last one we're going to do is example C. Okay, example C says we've got cross sections perpendicular to the x-axis still, but instead of it being a square, we've got a rectangle. Okay, and the height is 3. So I've already done the hard work. The side length of my rectangle is what? 2 minus x. So I'm going to call my length is 2 minus x. What is my width or my height? 3. So if I'm finding the area of a rectangle, what's my formula? 3 times 2 minus x. Or I'm going to say 6 minus 3x. And then to finish it out, we just got to do the integral. We're still going from 0 to 2. That didn't change because we're still in that same cross section there. But then our integral is going to be of 6 minus 3x dx. And again, we could evaluate that by hand pretty easily here, but save us some time if we plug this in the calculator. I think this one, yeah, comes out nicely to 6. So 6 units cubed. Okay. So that is squares and rectangles, almost all of them. We'll talk and finish about the rest of this next class.